So these lecture notes are chapter 23, part 1. You need to do this before you do the chapter 21 and 23 notes. Chapter 21 and 23 notes talk about confidence intervals. That will be the last thing we talk about before exam 2. This part, the first part of chapter 23, talks about expected value and SE for averages. So we've talked about it for percents. We just talked about that in the last chapter. And we started by talking about it for sum. So the expected value and the standard error for sum and for percents. With all of these, we can do the 6-step method where we start with a box model. Then we find the average and standard deviation. Then we find the expected value in SE. We draw our normal curve. We calculate the z-score, and then we can find the percent. So we're still going to be doing that same thing with averages this time. When we start preparing for exam 2, I will post a video with a summary of the 3 different types, sum, percent, and averages, and go through how you know when to use which. For averages, it's pretty easy. It will say averages. So for this one, it says right here averages. So you know, oh, we're talking about averages. This is just talking about how the empirical probability histogram will look like. The theoretical probability histogram. We've talked about this a ton. That's the central limit theorem. So I'm going to skip that slide. And that's what we talk about here. So this is central limit theorem. It applies to averages as well. We've talked about the formula for EV and SE for percent and sum. Here's the formula for EV and SE for averages. So the EV average is just the average of the box, and that will be given to you so that you will be given the average of the box and the SE of the box. Because you're given these two, you do not need a box model. So that means step 1 is not needed in the 6-step method, and step 2 is given to you. And then step 3, it's half given to you. If you're given the average of the box, you already know what the EV average is. And then the standard error, you just use the given SD of the box and divide it by the square root of the number of draws. Okay, so for the Gettysburg Address, what's going on here is each word is assigned to a number. And if we were in class, we would go through and randomly select 10 words, but we as humans can't actually randomly select. So we would pseudo-randomly select 10 words, calculate our average for each individual, and then our average as a class, and see how close it is to the actual average. This is an example where somebody took a random sample of 30 words and got the average for those 30 words was 4.3 letters long with a standard deviation of 2.12. So what we're talking about is how many letters each word is when we select those random 30 random words. We need to calculate the EV and the SE average. So step 1, box model. The box model holds every single word. So it's a ticket or a box containing tickets that show each word of the Gettysburg Address. We don't need that because the only reason you use a box model is to get the average and the standard deviation. And we're given that information. So this is not needed. And we just talked about this, but again, it's not needed because we have average and SD. Okay, step 2, we need the average of the box. So the average from those 30 words was 4.3 with a standard deviation of 2.12. We are asked to calculate step 3, the EV average. And the SE average. And so if we look back, the EV average is just the average of the box. And this is the formula for the SE average. Average of the box is 4.3 letters. And the standard error is the standard deviation divided by the square root of the number of draws. Looks like that is approximately 0.39. Okay, what is the chance the sample average will be between 4 and 5? This asks, what is the chance? That tells you use shade norm. When it asks what is the chance, it's either asking a probability question like chapters 13 and 14. And that will be talking about a small number of small number of like cards. So 52 cards or a certain number of marbles, something like that. Most of the time when it says what is the chance though, it's talking shade norm. So with this one, we already have step 3. We're going to do the 6-step method. Step 3, we got 4.3 and 0.39. Okay, so the expected value of the average of the, for the number of letters of the words in the Gettysburg Address, we expect 4.3, give or take 0.39 letters. We want to know the chance that it's in between 4 and 5. So step 4 is to draw the normal curve. The average is 4.3. So we're going to take between 4 and 5 and calculate that area. Step 5 is to find the z-score for each. So what we want minus the expected value over the standard error. What we want minus the expected value over the standard error. So it looks like it's negative 0.77 standard deviations away for 4 letters, and 5 letters is 1.79 standard deviations above the average. So the last step is to plug it into shade norm. Negative 0.77, 1.79, 0, 1. Ooh, my calculator's not up. Okay, so shade norm, we're going to go to vars, nope. We're going to go second vars, arrow over to draw, choose the top option, and then your lower bound was negative 0.77, upper was 1.79, not 179, and then always 0, 1, and choose your color. Okay, so there we can see the normal curve. Oops, that's a little bit too big. And we need the average, or the area. Looks like the area is 0.74, so 74.3%. So there's a 74% chance that the average from a sample we take will be between 4 and 5 letters. Now we want to know the chance that it's less than 3.8 letters. So step 4. 4.3 is the middle. So 3.8 is over here and it's less than, so we're going to shade underneath. Step 5 is the z-score. 3.8 minus the expected value over the standard error. Whoops, not 2.12, that was standard deviation. So that's going to be negative 2 point something. Oh, I lied. It's going to be negative 1.28. So this 3.8 is at a standard error of negative 1.28. And we are not given a lower bound, so we're going to use negative 10 to negative 1.28, 0, 1, and then we type it in. Oops. Okay, negative 10, negative 1.38. Let me make sure I got that number right. Negative 1.28. 0, 1. I don't like this calculator on my iPad because I can't always get it to actually show me the area if I've already done one. There we go. It's 10%. Okay. So that's how we deal with averages. And the way you know you're going to be dealing with EV and SE average is it will say average. So this one, manufacturer claims that its light bulbs will last for an average, oh look, it said the word average there, of 500 hours. So the average of the box is 500 with a standard deviation, not a standard error, standard deviation of 15 hours. Consumer organization randomly obtains 75 light bulbs, so that is our number of draws. Okay, step 1 is to make the box model. We don't need to make the box model. That box contains every single light bulb the manufacturer has made. And we're selecting 75 from that box. So step 2, we already wrote right here. So then we can just go to step 3, the EV and SE average. EV average is going to be the average we got from our random selection. Oh, sorry. No, it's not what we got from the random selection. It's what we know it's supposed to be. So the average is supposed to be 500 with a standard deviation. With a standard error of 15 divided by the square root of 75. So we get 1.73. Step 4. Oh, step 4 is on the next question because this one just asked for EV and SE. this was SE average, by the way. Okay, less than 70 hours. If you think about it, that's going to be clear out there because this is 500, give or take 1.73. So 70 won't even appear. So I don't have to do this one because that's so many standard deviations away from the average. That's going to be like, what, 300 standard deviations away from the average, something like that. I mean, we can calculate the z-score if we want. Here's step 4. 70 hours. 70 minus the expected 500 over a standard error of 1.73. Not going to quite 300. Negative 248.6 standard errors away. The chance of that happening is 0%. Okay, this just all talks about the same thing. If you want to do the problems, you can. I don't care about this survey stuff. Don't care about that. Don't care about that. Don't care about that. This only works if it's a simple random sample. If it's not, it doesn't work. And no homework assigned with chapter 23 yet. We will get to that at the end of the next notes. So really, the main thing you had to get from this was just how to work with EV and SE average. So you've got percent, sum, and average now.